Before the workshop starts, we're going to show you how to navigate through the video. Below the YouTube video is the Show More button. Click the Show More button to reveal the index. You can skip to the point that you want in the video by clicking the blue time link.
My name is Sheena McCourt. You've probably met me before, most of you. So, my name is Sheena, and today's workshop is going to be on statistics mainly. So if you have a wee look at what we're doing today, right up until lunchtime, we're going to spend the whole morning doing statistics and trying to bring ourselves through as much of the course from first year up to sixth year as we can, get a nice overview of statistics. And then after lunch, what we're going to do is we're going to do a little more statistics, and then we'll get into a little bit of algebra to finish off the day. So that's the plan. We'll do a little bit with our first years at the end of the day on algebra. Okay, so we'll get stuck right in. Okay. Do you want me to close over the door? I'll close over the door there. Thanks. Okay, so this is how we're starting. This is really an overview of a statistical investigation in statistics. So we call it the data handling cycle. You've probably heard about it before from your previous workshops. And basically, when a statistician or one of the kids wants to do a little investigation, what they need to do is they need to start off by posing a question. What is it that I want to know? Do I want to know the average height of the people in my classroom? Maybe I want to compare the average height in our classroom compared to the classroom next door. Or maybe I just want to compare the average height or the typical height in our classroom compared to the national average. So they just come up with what is it that we want to know. And I guess what might be hard for them is making it relevant, that it's an appropriate question for a statistic. That can be hard for them. So that's the first place that they start. What question are we going to ask? The next place they go to is, how are we going to collect the data? So they have to make some decisions on how they'll collect the data, who they'll collect the data from. They'll have to try and make sure that it's all fair, you know, that there's no bias in how they're collecting their data. So there's a few decisions to be made around that. So after they get all of their data, then it's up to them to analyze the data. And this is where our statistics come in. Okay, so how am I going to represent my data? What picture am I going to use? What statistics am I going to use? Am I going to go for an average or a median? Or am I going to look at the distribution, the max and the min? How am I going to describe what my data looks like? And then after all of that, they finish off their statistical investigation by interpreting their results. So they need to look at their results and see, how does that apply to the question that I asked? What does that tell me about the question that I asked? And that's their statistical investigation. So we'll be working through this all day. And what you're going to find in your workbooks there on page 4 and 5 is it's a roadmap for statistical investigation, okay? So at the beginning, you'll see we've got the information that they need for how to pose a question and how to collect the data. It's kind of like their little 2-page cheat sheet, you know, their overall picture, so that things don't get lost in little sections. It's the big picture. Then we've got a whole section here on analyze the data, all the things that they need to be able to talk about. Mainly the central tendencies, their dispersion or their variation, and the shape of the data. So that's there. It's a little guideline for them on how to talk about their data. You know, when you get those questions, tell me about the data. And they're like, I haven't a clue where to even start. Okay, so here they see, okay, there's 3 headings there. Maybe I'll try and say something about those 3 headings. And then finally, there's a little bit there on interpreting the results. So we'll be working through that today. Okay, so the first thing is, I guess, is if I'm thinking of a first-year class or a fifth-year class that haven't done too many statistics, how do you make it at all interesting? Okay, that is a challenge, isn't it? Because, I mean, to them it's statistics, big whoop, isn't it? So how can we make it interesting? Now, I don't know, have you heard of this guy, Hans Rosling? He's amazing. He's a Swedish mathematician and statistician. And what makes him very interesting, actually, is that statistics hail from Sweden. So he's all about his statistics, and he gets very excited about it. And what he has done is he has decided to try and convince the world just how beneficial and interesting statistics are. And one of the things he did was actually, he put a whole film together. It's called The Joy of Stats. You might look it up. It's a very, very good film. The Joy of Stats. Okay, and what I'm going to do is I'm going to show you a little clip from the film, just to show you what I mean. So he might pull the kids in on how interesting stats can actually be. Okay, so the first thing we have to do is look at what kind of questions you want to pose. So there are going to be 3 types of questions that the kids are going to meet in their school career. The first one, I guess, where you're starting out with your first years, is just a nice summary of a single variable of data. Okay, so in other words, as I was saying this morning, if you were wondering about the typical height in your classroom, well then what you're looking for is just heights, one variable. And you're going to look at that and do a summary of that. So that's where the kids are starting there. As they work up into second and third year, they might be able to then do a comparison. So again, they're just comparing one variable. So the heights in one classroom compared to the heights in another classroom. So this is really all your junior cert work here. It's all around investigating one variable. Now, when the kids get up into fifth year, this is where it changes a little bit for them, because then they have to get used to being able to deal with 2 variables of data. And when they're looking at 2 variables of data, what they're looking for is a relationship between 2 variables. So they might be thinking, they might look at, does your age have any relationship with the amount of homework that you do? Okay, do the 6th years do more homework than the 1st years? They might be interested in age compared to the use of the mobile phone. Or as we look at later, we're going to look at the relationship of a person's height compared to a person's arm span, and if there's any relationship between that. So those are the kind of things then that the kids will look at once they get up into their Leaving Cert curriculum. Okay, so the second thing then is they have to be able to collect the data. Now, what's lovely about the data is that we have Census at school. So we're able to sign up as a teacher to Census at school. And what happens there is when you sign up to Census at school, you get a questionnaire. Okay? So they give you this questionnaire, and this questionnaire you can give out to the people in your class, and they're going to do the questionnaire. And they fill it into the computer, and then what they get back is a data sheet of all their statistics. So what's brilliant about that is the kids will get to use raw, genuine statistics in the classroom. Instead of it just being out of a book and not meaning anything to them, it's going to be their own statistics and maybe how they compare nationally to other schools. Okay, so that would be the questionnaire. That's phase 10, so that was last year's questionnaire. Currently what is out is phase 11 questionnaire, and we have it up on the wall. You can have a look at it later, the phase 11 questionnaire. And what you get back then is some raw data. But what's really interesting about the questionnaire is we have to teach the kids about different types of data. And what's lovely is, where better to do it but a genuine survey. So the types of data that we have to look at with the kids are, first of all, some of the data is going to be words. the answers will be words, and some of the answers will be numbers. And that's the perfect distinction to make with your first years. We don't want to get into all of these fancy words with our first years. Sure we don't. We'd frighten the life out of them. We're happy in first year if they can say, that data is a word, that piece of data is a number, and they know that there's a distinction between the two. Then maybe when they become more comfortable with their statistics, we can tell them that there's actually two types of categories of word. So the fancy way we say data is a word is it's categorical data. Okay. So if you have a word answer, it's categorical data. Now there's two types within that. You've got categorical nominal and categorical ordinal. Now the easiest thing to do there is to explain what the ordinal is. Categorical ordinal is just how it sounds. It's ordered words. So in other words, you know those surveys where you have to tick, how much do you like school? Not at all, a little bit, it's all right, I like it, I love it. That's an ordered answer, and they have to tick one of those. So we would call that categorical ordered. And then every other type of word is categorical nominal. So if they can get the ordered bit down, all the rest are nominal. Okay, and then the next type is the numbers. And the two types of numbered data they have to look at is numerical discrete and numerical continuous. So the numerical discrete are all of the answers that are just the natural numbers, isn't it? How many people in your family? There's 5 of them. How many cans of Coke did you drink today? I drank 2 of them, okay? Compared to continuous data, numerical continuous, and I guess really this is just where you're bringing in your decimal points, isn't it? Where you could have any decimal point. So if I asked you what is your height, if you were to get very, very specific, you would say it's 163 centimeters, 0.172, and that's continuous data. Okay, so what I'm going to get you to do is, this census here is on your second page of your booklet. So in pairs, will you just go through those questions and just decide if they're categorical or numerical, and decide if the question is categorical nominal or ordinal or numerical discrete continuous.
I'm saying discrete and I'm writing down C. What's wrong with me? Sorry, I'm reading wrong one. 6B.
6B. So what is the length of your right foot to the nearest tenth of a centimetre? So I guess you could go there, you could go discrete because they have capped it. But in terms of representing that on a picture, you'd be a long time representing all of those intervals, wouldn't you? It's actually more continuous data, isn't it? That's continuous data. It's been rounded off way down to the nearest tenth of a centimetre for the purpose of them knowing when to stop. But you can tell that you wouldn't actually, if you plotted all of that discretely and tried to do a dot plot or something, it'd be this size, wouldn't it? Yeah. So what we'll move on to then is, the lovely thing with Census at school is once the kids do their survey, then they can get back some raw data. So let's have a look at the raw data then. It's on pages 5 and 6. So isn't that just lovely that they will, I mean, there's raw data of 200 students, okay, under all of the questions that they've just answered. And basically, couldn't you give that to them in first year? Laminated, you could use that right up to 6-year honours. Yeah. You can do all of your statistics off that data because you've got continuous, discrete, you have all your different types of data, so you're going to be able to tease out all your different types of representations, all your different types of statistics, instead of doing a million different ones in the book. Wouldn't that just make it that your class would flow so much easier? So we're going to use this a good bit today, okay? So that's the collecting of the data. Now, a nice way to collect data is a survey. Okay, now I've got two surveys for you here. And both of the surveys, the green one and the blue one, they both end with the same question. Do you think we should reduce the number of large supermarkets in our towns? And this one ends the same. Do you think we should reduce the number of large supermarkets in our towns? Now, what I want you to tell me is, which one of these do you think will return an answer of yes? I think we should reduce the number of large supermarkets in the town. So have a wee look at them. Have a wee read to yourself there. Which one do you think? The second one. Okay, so you think the second one might give an answer of yes, we should reduce the number of large supermarkets. Why do you think the second one would give you that answer quicker than the first one? It's more negative towards supermarkets. It's leading. That's exactly it, isn't it? It's a leading. The second one is a leading questionnaire with leading questions. And would you say then that that would be a fair questionnaire? No, it's not a fair one. And it's very important that the kids come to understand what makes a fair question, what makes a fair questionnaire. Because what are they trying to eliminate? Bias, exactly. This questionnaire is full of bias, and they have to come to understand what bias is and that it's their responsibility as the statistician to make sure that there's no bias in whatever they're asking. Okay, so I have a lovely clip for you now. I don't know if any of you remembered this. Do you remember Yes Minister and Yes Prime Minister? Do you remember those shows? This is a little story up here. It's really just to remind me of the story, okay? But I'm going to tell you the story. And this is really to help the students understand that when they go to take a sample, they've got a number of ways that they can choose to take their sample. So let's say I'm a girl and I work for somebody in town, maybe it's an estate agent, something like that, and my boss says to me, can you go and survey 10 households for me? And I want you to go down to that estate down the road and do it down there. So I have my brief. I have 10 households I need to survey, and the estate down the road I need to go to has 280 houses in it. So what am I going to do? Well, the first thing I could decide to do is I could decide to take a simple random sample. Okay, that's where I just choose my 10 numbers from 280 randomly. Okay, so you have a number of ways of doing that. You could pull numbers out of a hat, or you could use a random generator on your calculator. Can't you do that on your calculator? Type in, I'd like 30 random numbers or 10 random numbers from a certain pool of numbers. Okay, so I get my 10 random numbers. Now I might think, well, hold on. I'm going to be traipsing all around the estate now, surveying those 10 random houses. So to make it easier for me to get my sample, I might decide, well, I'm going to cluster the estate instead into groups of 5. And what I'll do is I'll randomly select 2 groups. So at least that way I only have to go to 2 clusters and I won't be running around ragged all around the estate. Okay, so that's cluster sampling to make it easier to take the sample. Now, I might decide after that, well, hold on a minute. In my estate, I've got 2-bedroom houses, 3-bedroom houses, 4-bedroom houses, and 5-bedroom houses. So it could turn out, because of randomness, that I'll end up taking 10 householders from 10 2-bedroom houses. So my sample might not end up very representative. So I might want to ensure that my sample is nice and representative of the types of houses in the estate. So I might decide to take 2 householders from 2-bedded houses, 2 from 3-bedded houses, 3 from 4-bedded houses, and 3 5-bedded houses. I'll split it up like that. And what I'm doing is I'm stratifying Okay, I'm stratifying into the different types of houses to make sure I get a more representative sample. Okay, so that's stratified sampling. But then after all of that, I'm after thinking, what am I going to do? My boss says to me on the way out, by the way, you have to do it in half an hour. So now, what do I have to do? If I only have a limited amount of time or resources, the easiest way to get a sample is quota sampling, where I have my quota of 10 and I do it in the easiest way I possibly can. So I'll just drive to the estate and take the first 10 houses that I see. So those are your 4 different types of sampling. Okay, so a simple random sample, and that's really where the kids start off in first year. Randomness and understanding randomness. Or I might make it into clusters to make it easier on myself, stratify my sample to make it more representative, or I might just do quota sampling to make it nice and fast. Okay. So over to you then. Here we've got a plane. And what we have is here in the blue seats are 8 people in first class. Then we have 60 seats for people in business class, the yellow ones. And then we have 224 green seats in economy. Okay. So we want to survey 30 passengers on this flight. How would you sample this group? Well, first of all, I might choose a sample from first class, a sample from business, and a sample from economy. So which of the 4 types of sampling am I doing there? Yes, perfect, stratified. You're making sure I get a nice representation, some of each class in the flight. Okay, the next one is then, I might just randomly generate 30 numbers and survey passengers who sit there. Simple, perfect, simple random sample. Or I might decide, do you know what, this is going to be too long. I'm going to get the passenger list from the air hostess and I'm going to split it into groups of 15 and just randomly pick 2 groups and survey them. So what type would that be? Perfect. And then lastly, again, I might be under pressure, or maybe I'm just lazy, or whatever, and I might just decide, do you know what? What is it that I want? I'd really love 15 males, 15 females, between 40 and 50. That's what I really want. So I'm going to stand with my clipboard as they're getting on the plane, and I'm just going to take the first 30 that meet my criteria. And that's your quota. Perfect. So those are all your different types of sampling. Perfect. Okay. So what we're going to do now is we have learned now how we're going to look at our sampling, how to take a sample, who, and to eliminate bias. So what we're going to do now is we're actually going to take a sample, and we're going to use our raw data to do that. So if you look at your raw data, again, it's on page 5 and 6 in your workbook. Okay, what you'll see is the data is numbered 1 to 200. Okay, and that's very useful that all of your data is numbered 1 to 200. The one that we're going to look at for this is, can you see about 7 rows across where they had to answer how many people are in your household, including yourself? Okay, we're going to look at that data. And what's nice about this is, if you follow the column onto the second page, do you see what's on the bottom of each column? The maximum and minimum. So from all of this data, the maximum was a family of 9, and the minimum was some poor student with 1, I don't know, living on his own. We call him a repeat leave insert living on his own somewhere. Okay, we don't know who that guy is. Right, but there's my max and my min. So what we're going to do is we're going to take a simple random sample from this of 30 of these kids. And we'll see what sort of distribution we get from their households, how many are in their households. Now, a simple random sample, I think if you're going to do it with first years, or it's the first time they've ever heard of it, the hat analogy is the best one, isn't it? Okay. So we put all of these 200 numbers in a hat, and we pick out our first random number. Okay, so it's a 6. Right. Now, what are the chances of that being picked out of those 200? What are the chances of the 6 being picked? 1 out of 200. Perfect. So now I have 6. Right, I pick my next number. It's a 100. What was the chance of that one being picked? 1 out of 199. Now we have a problem here because this is not a random sample anymore. In order for something to be a random sample, every single number in my hat must have an equal chance of being chosen. So what did I need to do with the first number that I chose? I needed to put it back in the hat. Okay, so once they understand that, then we can tell them, well, they can do it on their calculator. They can get random numbers from there. But then through talking about the hat, they understand that when the calculator is giving them random numbers, what might happen? Yeah, the same number might come up twice because the calculator keeps replacing the numbers as well. And if the same number comes up twice, we just ignore it and go again because we've already had it. Now, because of that, because the calculator can give you the same number twice, what do you have to make sure you do as you're taking your data? You'll have to mark it off, won't you? I already took person 5. I already took person 120. Mark it off in case it comes up again. Okay, so what we'll do is, you're going to do that in your groups, but before you do that, I'm going to run through how to do this on the calculator just to make sure we're all up to speed on that. Okay, if I can find me thingy-me-bobby, yeah. So the first thing is, what you have there is a Casio calculator. There's a few extra ones here, okay? And what I'll do is, I'll show you how to do a random sample on the Casio, and then after that I'll show you how to do it on the Sharp in case any of you are using Sharp back at school. Okay. So the first thing is, on your Casio, can you see this red word over the decimal place? Random integer. Okay, so that's what we want. It's some random integers. Okay, so what we'll have to do, because it's red, we need to select it using the alpha button, isn't it? We use the shift button to select the yellow ones, the red button to, the alpha button to select the red ones. So select random integer, and it'll come up like that. And what's lovely about this is, it offers us up a bracket because it's saying to you, what is the pool of numbers that you want to take your random sample from? So what's the pool of numbers we want? 1 to 200. So we'll put in our 1, and then our comma is yellow this time. It's over the bracket. So because it's yellow, we need the shift button this time to select that. Okay. Put in our 200 and then close off with our bracket. And then what happens, guys, every time we press equals, we get a random number between 1 and 200. Okay. So the next thing then is your Sharp calculator. So if anyone is using Sharp, the Sharp calculator back at school, you know that it's a little bit different for getting the random sample. Now your random is over the 7 in case anyone has a Sharp calculator. And you see here what comes up is you have 4 choices. This is a random number here. It's a random decimal actually. This one here is a random decimal between 0 and 1. This one's a random dice, so it'll just be between 1 and 6. Random coin toss, just be tails or heads. And random integer. Now the thing with the Sharp at present is that the random integer just gives you the integers between 1 and 100. Okay, you can't tell the calculator what set you want to take it from. Okay, so because of that, what we do is we use this one here instead, the 0, the random integer. And I'll just show you how that works. Okay. The random integer, because it gives us a nice bounded set between 0 and 1, we're going to manipulate it to our own advantage. So it will give me between 0 and 200, or sorry, between 0 and 1. So it's going to give me decimal answers. Okay. So what we could do is, if we wanted my set, instead of it being between 0 and 1, what could we do? Yeah, exactly. You might, if you multiply it by 2, it would be between 0 and 2. So if we wanted up to 200, what could we multiply by? 200. Okay. So we could multiply by 200 by the random button. Okay. Now, the only thing there is that if you do that, it will give you the set between 0 and 200, which is nearly what we want, but we don't want the 0, isn't that right? So what we're going to do is we're going to take 1 off the 200 and add it on to the end, and that will remedy that for us. We'll have no 0 then because of the add 1 on it. So what we'll say is 199 instead of 200 times the random button and then plus 1. And the plus 1 then will make sure I won't get that 0. So this will actually then be between 1 and 200. Okay. So I guess if the kids have a sharp, they would just need to know that if whatever my set is, drop 1 and add it to the end, and that will get me my perfect set of numbers to take from. Okay. So we would press the random button. Now, you can, if you want, fix your calculator, okay, so that the answers won't be decimal points, because aren't all of these decimal points? So when we multiply, the random numbers from here could be 37.5, okay? Now, what you could do is you can fix your calculator to integers, or you can just tell the kids, just ignore the decimals, okay? That's up to yourself. It might be easier to tell them to ignore the decimals because they might forget to put it back and not fix it, isn't that right? And they go on and do their sums with their calculator fixed. But they could fix it if they want. So we see 199 random plus 1, and then we'll get our random numbers. Okay, so that's the plan of action. Now, so the plan is, what I would like you to do is to take a sample of 30 pieces of data, okay? So what I'll do is actually, guys, I'll hand you out rulers, because you're going to say you're in pairs. So one person will get the random numbers and say 36, and you'll go to 36 and come across and get your data, and you'll see 5 people are in the family, the 36th student, and the 5 is your piece of data, isn't that it? And once you get your 30, then I'm going to ask you to put it onto a dot plot. Okay, so your dot plots look like this. This is a dot plot. So I did one last night. I took a wee random sample, and this is how my one came out. Okay, so you can see there that, why does it go from 1 to 9? That was our max and our min, okay? And then you can see the nature of a dot plot is that we don't have to have an axis going up the side. Because if this was a bar chart, wouldn't we have one going up here to tell me how many are here? But the nature of a dot plot is we don't need that. It's the number of dots tell me how many students had a family of 4. So that's the type of thing you're going to make up then, okay? And I'll leave it over here so you can see it. So that's the plan. I'll give you out rulers. You're in your wee groups there, so you can make a start.
82. 151.
Okay, guys. Let's have a wee look at our dot plots. Now imagine you're 13, okay, and you're in class and you're looking around at everyone else's dot plot. Might you notice anything? Mine's different. What did I do wrong? Mine's different. Exactly. And that brings up such an important concept for us that underlies statistics, is that there will be sample variation. And we need to explain that to them, that no two samples will necessarily be the same because you've all taken random numbers. But the nice thing is, even though there is sample variation, what might you notice about your graphs? Were there any sort of trends that jumped out? 5. Yeah, the number 5 really jumps out, doesn't it? I actually, I couldn't put my last two on because I hadn't enough room. The 5s are just really the predominant one there, isn't it? The predominant piece of data is 5. Okay, so what else could we talk about here? We could ask them maybe for the max and the min in their own distribution. And maybe just simple language, because we don't want to get them into too heavy language just yet. So we might just ask them, well, where is the majority of your data clumped? Where would you say the majority of the data seems to be clumped? Around 5? 4, 5, 6. Yeah, exactly. That's really good. So around 4, 5, 6, the majority of my data seems to be clumped together. So what we're doing is, informally with the first years, we're getting them to talk about the shape or the distribution of the data in nice simple language and have the chats with them about that. Okay, perfect. Right. So the next thing then is we need to learn how to analyze the data, isn't that it? And you've already started to do that with your dot plot. Now, as we know, there are lots of different graphical representations. So let's see the ones that they'll be expected to master over their school career. So the first one is the nice bar chart. Okay, and they've always had to do this, so this is nothing new. But I guess what's different now is, you know, before in a question, the students would generally be asked, here is your data, and presented on a bar chart. Whereas what's more typical of project maths is, here's your data, draw an appropriate representation of the data. So they won't know, do I use a bar chart, do I use a histogram, what do I use? So they need to learn why the different representations are useful or appropriate in different situations. So what do you reckon the bar chart's really good for? What does it display? Why would you choose a bar chart? Yeah, absolutely, the different heights. And the different heights of the bars, what does that tell us about the data in each bar?
Well, it will tell us how many people are, you know, in the average height, and how many people are below average or above average height.
Yeah, perfect. Yeah, absolutely.
If you do an in-class survey.
If you do an in-class survey. And so if you were doing an in-class survey, you think that maybe a bar chart is good for displaying the frequency of people in certain categories as well, isn't it? And what's nice about this is, it's really good for comparing frequencies at a glance, isn't it? At a glance. But what type of data? You wouldn't use this for every type of data. What type of data would be appropriate to this bar chart? So we had our 4 types of data. What ones do you think you might go for first? Categorical, nominal, perfect. Very good. So the wordy ones, the categorical, nominal, What do you think about the categorical ordered? It would depend, wouldn't it? If it was the one that you had there where you just had to mark a dot and a line, that wouldn't work out. But if it was maybe 4 boxes of I like, I love, I hate, it's all right, you might put that on a bar chart. So very often you tend to put sort of more discrete data onto a bar chart. And this is why, and this is I think a little bit new for us. Do you see the way the bar chart has gaps between the bars? So before now, we wouldn't have been overly concerned with gaps or no gaps or whatever in the classroom. But now it's important that they use the gaps on a bar chart, because what they're telling the person viewing the bar chart is that they understand they're representing discrete data. So the gaps tell me that this is discrete data. So when I see a bar chart that's all stuck together, what's that going to tell me about the data? It's continuous. Perfect. And that's this one over here. Here's all our bars stuck together. Straight away I know this is continuous data. And actually I don't really call it a bar chart anymore when it's continuous data. What's the other word for it? A histogram. Perfect. Okay, so we've bar charts and histograms. Then we have our pie chart. So what's our pie chart particularly good at showing us?
The percentage of the total of 100%, the breakdown.
Exactly.
Yeah.
Perfect. So it's the percentage of the total. And that's what's nice here. It's showing you a relationship with the total. It's showing you the ratio or the proportions. Okay. So very good for showing you your proportions and your percentages. Excellent. And then we've got our little dot plots. Okay, so you've already done a dot plot, and I think we talked about then that one nice thing is we don't need this axis, isn't it, with the dot plot. Now, what's also nice is, let's say we did this in the classroom, and instead of using this, I asked you, how many people do you have in your family, and you, and you? And we could get them up to the whiteboard with these things, couldn't we? And you come up and put your value on. This is you. I've got 5 people in my household. That's my piece of data. It's going to go right there. So it's like, it keeps it more individual, doesn't it, the data? So it's nice from that point of view, a dot plot. Okay. What's this guy here? Yeah, a stem and leaf. So this is new to them, isn't it? A stem and leaf is new to the course. Now, really, a stem and leaf plot, it's the exact same thing, isn't it? It's nearly like the bar chart on its side or the dot plot on its side. It's showing you the same type of distribution, okay? But there are 2 things about this that's really nice. Not only now will I be able to see my individual dot, I'll actually be able to see my actual answer. So say this looks like I went to a party and I surveyed some people's ages, doesn't it? It goes from 19 to 62. So let's say it was that. So if I'm 34, I wish. If I was 34, okay, well then I would know that this one, 3, 4, that one there is me. That's me right there. So you can really see the individuality of the data. But again, you can still see the distribution, can't you? The majority of the data there is clumped around the middle, isn't it? You can clearly see the distribution. Okay, so actually these 2, you see this one here and this one here, they're very good then as well for comparing. Remember I said when you get up into 2nd, 3rd year, the kids might start to compare our heights or our families to the ones in the classroom next door. And in that way then, a bar chart's very nice for comparing, isn't it? And that's where the kids then look at things like a back-to-back stem and leaf, where this is maybe the people in the party in one pub, and this is the couple of people at a party in the pub down the road. Okay, and you can compare. Okay. Another nice thing about the stem and leaf is, you know the way this one, the bar chart and the dot plot, it's not overly appropriate for continuous data. Sure, it's not. Be more trouble than it's worth. But for continuous data with decimal points, if your decimal point isn't too far along the way, you can use this one here. So you can have decimals in your stem and leaf. So we could change all of these to 1.96.2. If we just tell our key that 19, instead of it equal 19, it equals 1.9. And then I can use that for my continuous data as well. So this is the last guy. And this is for the leave inserts, isn't it? Remember, they then have to talk about two variables. Okay? So to represent two variables, they only have the one representation that they have to come to terms with, and it's this here. What's this? A scatter plot. Perfect. So that's the last one, the scatter plot. Okay. And you see this here, it's been made into a poster, and it's on the Project Maths website as well. So if you want to print it off and put it on your wall and get them used to deciding what's appropriate for what questions. Okay. So now that we've represented our data in a nice diagram, we have to then try and do some statistics on it and try and get some meaning from the representation. So do you remember I said this morning the first type is your central tendencies? Okay. So we'll have a look at those. They're going to be our mean, our median, and our mode. Those are our central tendencies. Right. So here we have something, a little distribution, where I can see that my mode is 5. And I like this diagram here because it shows me that the dot plot is the same thing as the bar chart. It shows me very clearly that they're one and the same. Okay, so that's my mode, and the mode's the most frequent. They're usually okay with that one, aren't they? Okay. The next one that we're going to look at is the median. Okay. So here's some people. They work in an office. And what I'm going to ask you is, what is the range of heights of people in the office? What is the median height of the people in the office? And what is the range and height of the middle 50%? Now, there's a reason why I have asked this question and this question along with my median. Why haven't I just said, what's the median? Okay. And there's a reason for that. So let's say I say to you, I've got a distribution here and the median is 6. What does that mean to you? So the middle number placed in order is 6. Okay. Does it tell you anything else about the distribution? Exactly. It tells you it's in order. It doesn't tell you a whole lot, does it? Somebody walked up to you and said the median's 6. Great for you. It doesn't mean anything. Sure, it doesn't. That's why the median is one of those statistics that is better in context. Because if I said to you, I have a distribution here, and my range of values are between 1 and 100. Now, the median is 6. What does that mean to you? Yeah, absolutely. All the data is very small. My range goes from 1 to 100. My median is at 6. What does that tell you? If your middle number's at 6, but your range is 1 to 100, what does it tell you? Exactly, it's skewed. All of your data is where? It's all clumped to one side. Exactly. It tells you something if you give the context to the median. Okay, so that's why we're going to look at the max and min of this, and we're going to look at the middle 50% as well, because that gives me even more context. Okay, so as you quite rightly said, the first thing we need to do is order the data. So we'll check out their heights and order the data. Okay, so now they're all reordered. So the first thing that we will do then is we'll give ourselves the range, a good frame of reference. So we'll measure the person on the top, and the person at the top of the line, and the person at the bottom of the line. Okay, and this came up here, a 5-number summary, because this is a nice way of looking at it. Instead of asking the kids for a for a median, ask them for the 5-number summary, which is going to be the max, the min, and what tells me about my middle 50%? Yeah, the interquartile range. It's the first quartile and the third quartile and the median. So those are my 5 things that I'm going to look at. So instead of saying to the kids, what's the median? Give me a 5-number summary and tell me about the median. Okay, so we're getting the max and the min here. So we'll measure these guys. So this chap is 187 and this lady is 160 centimetres. So there's my range. Then we have to get the median, so the middle data point. Okay, what happens though when I have an even number of people if I want to get the middle? Exactly, it's in the middle. I have to get an average of 2, exactly. So my median is here, it falls between 2 people, so we'll have to measure those 2 people and get the average of their heights for the median. Okay. And then the last 2 things in my 5-number summary are looking at the middle 50% or the interquartile range. So I need the first quartile. So quartile is really just quarter, isn't it? So a quarter way up will then be, here's my 6 people, it's going to be here, isn't it? So we're going to fall into the same problem. We'll have to take 2 heights and get the average. So there's my first quartile. And then my third one is 3 quarters. We don't get 2 quarters, isn't that right? Because that's the same as the median. Okay, so 3 quarters. And now I've got my middle 50%, the range for my middle 50%. Okay, and again, that's online. You can download those PowerPoints for yourself if you want. Everything today is under Workshop 5, the tab, okay, online. Right, so here's another way that could be nice with your kids to get them practicing. If you wanted to, you could bring in some spaghetti, not cooked, okay? Some uncooked spaghetti, and give them all a strand each. And say, take your spaghetti, I know, you have visions of the spaghetti coming this way, and break up the pieces of spaghetti into 11 pieces, or 10 pieces, or 7 pieces, depending on what you want to test with them. And just say to them, off you go, get me a 5-number summary. And what will they have to do with their pieces of spaghetti? The kids will have to, and this is nice because they get to do it instead of just listening about it. Rearrange their spaghetti. Now, get my max and my min, so they'll have to get the longest one and the shortest one and measure those for their max and their min. Now, when it comes to the median, I can tell you I have 11 pieces of spaghetti here. So how is this going to be different to the last example? Exactly, it's actually going to be a data point. So right in the middle of an odd number will actually be a data point. You can get them to pull them away this side until they reveal the one in the middle. And that's our median. Okay. And then after that, we need to get our interquartile range. Now, there's 2 schools of thought on this, and both are acceptable. The first one is, if you want, you can count the median. You know, when you look at this data, you can say, well, I have the median, so I have this one, 1, 2, 3, 4, 5, 6. The middle of those 6 will be here. Or another school of thought is just some people exclude the median and say, that's my median, so what I've got left on this side is 1, 2, 3, 4, 5, so that one will be my middle one. Okay, both are okay. So whatever one the kids find easiest. Okay. Right, so what we're going to do now is that okay with the median? And then the last one we're going to look at is the mean. Now, we're going to look at the mean in terms of a fair share. Okay, instead of mean, we're going to try and give them a little bit of understanding first. So, I'll set these up. This is where I go all blue Peter. And you just have to bear with me because these usually fall over and all that kind of stuff. Right. So instead of spaghetti, we could use these, couldn't we? These might be a bit easier to use than the spaghetti, right? And you all have these at this stage in your classrooms, do you? Yeah? If you don't, I tell you, they're so brilliant. They're so versatile. Okay, so what we're going to say is here I have 45 sweets. Okay, so each little block is a sweet. And I've 9 students. Okay? And each student has gotten some sweets. Right. At the moment, this distribution of sweets, okay, is it fair? No, it's not very fair. Okay, so we'll keep that in mind. And the next thing that we're going to do, so we've noticed my distribution isn't fair. A nice thing to do would be to get our 5-number summary, wouldn't it? Give us some feeling for this distribution. So what's the first thing that the student is going to have to do? Put them in order, exactly. So we have to put them in order. Okay. Wouldn't they be much more likely to remember this now in a question if they'd actually done it like this? Right, so to put them in order. So now, what one is my maximum? This guy here. 1, 2, 3, 4, 5, 6, 7, 8 sweets is my maximum. What's my minimum? 2. So this poor kid only got 2 sweets. Okay, so my max is from 8 to 2. Next thing we'll do is we will get our median. Okay, so we're going to have, am I right? 1, 2, 3, 4, 5, 6, 7, 8, 9, yes. So our median then will be a 5. Okay, so I'm going to write those up now. So I'm calling this one the demo, okay? Right, so the max was 8, isn't that right? The min was 2 and the median was 5. Okay, now I have to see what is the mean. Okay, so if I come back to my distribution now, okay, we're going to talk about the mean. And the mean is really going to be about a fair share of this. Okay, so at the minute it's not fair. So what we're going to do is we're going to make it fair by evening out the sweets. And the fair share that everybody gets is going to be the mean of this distribution. But not only that, I want you to count for me the number of moves it takes me to make this fair. Okay, so over here we've got, I give this guy 1 sweet. I give him another sweet there. That's 2 moves, isn't it? 3 moves. 4 moves. 5 moves. 6 moves. 7 moves. Okay. So after 7 moves, I have a fair distribution. And what's a fair share? 5 sweets. Okay, so 5 is my mean, my average, okay, a fair share. So let's write that up. So my mean is 5. Oh, I'll use a green one. My mean is 5. And how many moves was it? 7. Perfect. Okay. So keep that in mind now. So what we're going to do now is we're going to have a look at these distributions. These are, again, my 9 students and my 45 sweets distributed. And we're going to have a wee look at the distribution A and the distribution B. Okay, so if I look at A there, okay, so do you want to call it out to me? What is it? It's 6. Perfect. Perfect. 4. Perfect. 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 Lovely. Okay. Now, what's the first thing that you might notice about this distribution compared to the last one? Yeah, it's better, isn't it? It's better for the kids because it's more even, exactly. This is more fair. So we'll have a look just very quickly then at the median. So we'll put them in order. Okay. What's my maximum? That's a 6. And my minimum is 4. Now can you see, you thought this was more fair, more even, and look at my range of values are only going from a 6 to a 4. That tells me a lot about the variation in my distribution. Okay, and then we'll get the median. And the median is 5. Okay, perfect. And then we'll get our fair share. Now we know it's 45 sweets and 9 kids, so what do we know our fair share is going to be? Now, what do you expect about the moves this time? It's going to be less. Perfect. So that's interesting. There's going to be less moves when the distribution was more fair or more even. Okay, so just the 2 moves. So I'm going to write that up. So this time, my max was 6 and my minimum was 4. So less variation in that range there than this one. My median was 5, my mean was 5, but this time I only needed 2 moves. 2 moves. Now we're going to look at distribution B. And can you tell the words that I'm using all the time? It's the kind of language that the kids need to get used to, you know, looking at the distribution. Because it's not the stuff they find hard when the question says, describe to me, and they're like, I don't know where to start. It's the language that's difficult. Okay, so B, do you want to call that out for me as well? It's 1, 10, 10, 1, 1. Oh, 10. Perfect. Okay. What's the first thoughts on this distribution? Very unfair. Okay, very unfair. So let's first of all look at the 5-number summary, or the max and min. So we'll rearrange our data. Now, what do we notice now about the max and the min here? Huge difference. And the huge difference in the max and the min is going to tell me something about just the amount of variation or variability I had in that distribution. Okay, and let's see, let's get our median. One. Now, that's really interesting as well, because when you have something that's so varied like that, distribution there, your median may not necessarily be close to your mean. Okay, so we've noticed that's a clue to us anyway. If the mean and the median are very different, we know that we've got an odd type of distribution anyway. Okay. And then lastly, let's look at the moves. So do we expect a huge amount of moves here, realistically, isn't it? So let's see. So I'm moving 4 sweets. 4 sweets, it's 8 sweets. Okay, 4 more, so we have 12 sweets there. 4 more is 16 sweets. And then I need 1, 2, 3, 4. So how many sweets is that moved? 20. Perfect. Okay. So we had a max of 10, a minimum of 1. My median this time was 1. My mean is always going to be 5. And this time I had a huge amount of moves, 20 moves. Okay. So really, what we are doing here is we are discussing a distribution and variation variability in a distribution or the spread of the distribution. And that's a really hard concept for the kids to come to terms with. In fact, it's so hard that actually it's more of a leaving cert type situation where we really want them to talk about the variability in the distribution.